Welcome to yet another session on business statistics. In this session, we will learn about cumulative frequency distribution and quartiles, deciles, and percentiles. Cumulative frequency distribution is helpful when you cumulate the data, you get a broader picture or better picture about the entire data, and that will allow you to take certain decisions. We will see a couple of examples in the PowerPoint presentation. You will be able to appreciate how cumulative frequency distribution can be applied for nominal data as well as cardinal data. When you use cumulative distribution for cardinal data, you call them as OGIVES. There are two important OGIVES, less than ogive and greater than ogive or more than ogive. We will understand by way of the example which I have taken about the employees in an organization. And as far as quartiles, deciles, and percentage is basically the entire bell curve is divided into 4 equal parts in quartile and 10 equal parts in decile and 100 equal parts in percentiles. Of all the three, percentiles are most useful because a lot of population data are built on percentiles, and you have to simply use the chart whenever you wanted to. For example, the pediatricians extremely find useful the height weight chart, percentile chart, because the formative age, very important is the height, weight and head circumference of the children. So if that is in the normal development, the entire body or the entire child grows, or that organs are also developing well. So it's a very important parameter one has to understand. Also, you will understand that percentiles alone is not sufficient. By the second example, you may have to convert that percentiles into absolute numbers, then you will know where you stand, and that will help you to take certain decisions. With this, we will proceed to the PowerPoint presentation. Now let us understand how we build cumulative frequency distribution. In the last session, we saw the age of employees in an organization, and this is the replication of the data. Now let's move on how to build a cumulative frequency distribution. So the class intervals, which are 20 to 29, 30 to 39, they are all defined as less than age in cumulative frequency. Say for example, the first one is less than 30 years, second one is anywhere between 0 to less than 40 years, so on and so forth. So this is what you mean by less than cumulation. Okay. Now under this, what you do is that when you consider the age of 20 to 29, it was 5 only. Now with age less than 40, you will find it is 5 plus 6, 11. Likewise, you have to build it up, and this is what is called less than frequency, cumulative frequency distribution, and it is also called less than ogive. Okay, you can see the same is plotted here, and that is what is the frequency, cumulative frequency curve. Same way, now you have greater than 20, all the employees are greater than 20, so 29 is there. Then greater than 30, so you have to less those who are between 20 and 30, so that is how it becomes 24, like that. And correspondingly, you get the more than ogive curve like this. So this is the way you build cumulative frequency distribution. Now let us try to understand how we can use this graph effectively. For example, let us take an age of 50. So when you take the age of 50, straight away from this point you will get that 25 employees approximately are less than 50 age. I repeat once again. So when you take the age 50, draw a straight line and also see the corresponding horizontal line on the frequency y-axis scale. So you get 25. Similarly, if you take more than ogive, an age of 45, you will find that more than 15 people are above the age of 45. So this is a small example I have taken. Suppose you have a large sample running into hundreds or running into thousands. When you draw this cumulative frequency distribution, this is a ready reckoner where you can find out whatever information you want from the x-axis moving on to the y-axis. Cumulative frequency distribution gives additional information as we accumulate the data. You can see by this example, we have considered the airline's performance, okay, and another example, the age of the employees. First, let us discuss about the airline's performance. Just by glancing at the data of a cumulative frequency distribution, the management can understand about 65% of the issues are related to missing baggage and refund. Okay, right? So if they are able to address this missing baggage and refund issues, they will definitely improve their credibility. And just by looking into and be conscious about flight arrivals and departures, there are delays in terms of that, you can substantially improve to 85%, okay, of the issues can be addressed. So this is the way you understand using a cumulative frequency distribution. Now let us come to the example of employees in the organization. Now by looking at the cumulative distribution, you can understand the organization have fairly young employees, close to 40% in the age group of 20 to 40. Okay, and another 40% in the age group up to 50. That means what? You have more experienced people, and by looking at that, 80% of the employees are pretty good for the organization in terms of value addition. So the HR chief can relax about it. All he has to worry about, few people who are going to shortly retire. So step by step accumulation gives improved understanding of the data. That is the information we get out of cumulative frequency distribution. Now let us understand about quartiles, deciles and percentiles. These are positional parameters, and the data need to be organized in the ascending order or descending order. Quartiles is dividing the bell curve into 4 equal parts, and that is what we see here. And this is the first quartile, this is the second quartile, this is the third quartile, and this is the fourth quartile. It can also be understood that 25% of the data are less than Q1 or the first quartile, and 75% of the data are more than Q1 or the first quartile. Again, 50% of the data are less than quartile 2, and 50% of the data more than quartile 2, and 75% of the data are less than quartile 3, and 25% of the data more than quartile 3. Now when you divide the bell curve into 10 equal parts, then it becomes the decile. So that is the way you can understand. Now when you divide the bell curve into 100 equal parts, then it becomes a percentile. In the next session, we will take a couple of examples to understand about percentiles.